Hello. Now we start examples and differentiation rules. The first one being the power rule. We're going to do some examples and we'll see how the power rule comes in. So let's start asking questions to ourselves. What is the derivative of 0? Well, the derivative is the slope of the function. Here we're talking about the function y equals 0, which is just that horizontal line, the x-axis. And what's the derivative? Well, the slope of that line, which is 0. The next one is the line y equals x. What is the slope of the line y equals x? Rise, which is 1, over run, which is 1. The slope is 1. So, and it's constant. So if you have a line, the slope is constant. So the derivative of a line must be constant. We conclude that the derivative of x is just 1. 2x. Y equals 2x. Slope, 2 over 1. So the slope is 2. The derivative is the slope, so the derivative of 2x is just 2. Look, if we see the first example, we can conclude the derivative with respect to x of any constant is going to be a horizontal line, right? So the derivative of any constant is going to be 0. And from these other two examples, we conclude that the derivative with respect to x of a line mx plus b is always going to be m, because it's the slope. The derivative is the slope of the line. Let's try the parabola. Okay, so the parabola is not as simple because it doesn't have a constant slope. It varies. So we have to do it by using the definition. F of x plus h minus f of x over h. Here, f of x is the parabola, x squared. So this is the limit as h approaches 0 of x plus h squared minus the function x squared over h, which is the limit as h approaches 0 of x squared plus 2 xh plus h squared minus x squared over h. The x squared cancel, and we have that this is the limit as h approaches 0 of, I'm going to factor an h here, and that's 2x plus h over h. H cancel out, so we get this is the limit as h approaches 0 of 2x plus h. And when we take the limit, this approaches 0, so this is 2x. So the derivative of x squared is 2x. Let's go one power higher. It's going to be the limit as h approaches 0 of f of x plus h minus f of x over h, our definition. And our function is x cubed. That's the limit as h approaches 0 of x plus h cubed minus x cubed over h. And that's the limit as h approaches 0 of x cubed plus 3x squared h plus 3 xh squared plus h cubed minus x cubed over h. And the x cubed cancel out. We're going to factor an h in the top. So this is h times 3x squared plus 3xh plus h squared over h. The h's cancel out. And when we take the limit as h approaches 0, this is going to approach 0. H squared is going to approach 0, and we're left with 3x squared. So the derivative of x cubed is 3x squared. Let's analyze this a little bit more to find the power rule. So look, the derivative of x is 1. The derivative of x squared, the 2 came up to the front, and in the exponent, we have 2 minus 1. For x cubed, the 3 came to the front, and the exponent is 3 minus 1. Can you guess what's the power rule? So yes, the n goes to the front and subtract the power by 1. Let's look at some examples. Let's do d dx of x to the 5th power. So the 5 comes up to the front, and you lower your exponent by 1. So this is 5x to the 4th power. I'm sure you can do the next one. D dx of x to the 9th power. That equals, yep, the 9 goes to in front and lower the power by 1. Easy, right? The power rule also works for negative exponents. So if we want to do d dx of x to the negative 10, for example, you would have this number comes up to the front. So this is negative 10 x, and you're going to take the power and subtract a 1. So that's negative 10 x to the negative 11. I'm sure you can do this alone. X to the negative 7. That's going to be the number to the front, negative 7, x to the negative 7 minus 1, negative 8. But the power rule also works for radicals. We can compute d dx of square root of x. Just write it as a rational exponent, and we're done. X to the 1/2. What the rule says, bring the power to the front, the 1/2, and subtract 1 from the exponent. So this equals 1/2 x to the negative 1/2, which is 1 over 2 square root of x. One more. Try to do this one before I do it. The derivative of the cube root of x to the 4th. So write it as a rational exponent. That's x to the 4/3. And the rule says, bring the exponent to the front and subtract the power by 1. So we get 4/3. X to the 4/3 minus 1 is x to the 1/3. So this is 4/3 cube root of x. Thank you.